I chose to go to CppCon because there's plenty of opportunities to both have a lot of fun and network. You can come here to just learn and study, and there's a great community behind it.
All right. Hi, my name is Jody Hagins, and today I'm going to talk about some design guidelines, though you may not think that's what they are. I'm going to talk about design in respect to testability. In particular, not just writing functions or classes. That gets talked about a lot of times, and it's what we pretty much all expect when we think about testability. But this talk contains some content which may be highly opinionated. So if you want to reach out to me, there's my contact information. Please feel free to send all the email you want to that email address. Seriously, if you really want to contact me, you can reach out to me at this one. This is the real one right here. I will accept any email you want to send me, good, bad, ugly, whatever. Before I go on, this slide is from my CppCon 2022 talk when I was talking about some of my history. And I left grad school early, in large part because I won the lottery. Now, I didn't win the money lottery. I won the life lottery. And I went to Vanderbilt for a PhD, and I left with an awesome wife. And some of you have known about her recent struggles, and you've asked me. So I just wanted to let you guys know where things are. In 2016, she was diagnosed with stage 4 metastatic melanoma. In January, they said within 12 months, 93% of the people in her state are dead. Few years later, 5 years later, she's here, and she was diagnosed with breast cancer. And then a year later, stage 4 metastatic breast cancer. And so we just got back with her initial treatments a couple of weeks ago. She had tumors all over her body, in her lungs and liver and elsewhere, and they've all reduced dramatically in size and in the intensity uptake. I really appreciate the thoughts and prayers of this community because a number of you have reached out to me, and I just wanted to say thank you. Because really one of the big things is that we're all here for C++, but in the end, we're all real people with real lives. And I just wanted to say thank you for the support that you guys have shown me during some really hard times over the past few years. Thank you. So the title for this talk came from one of Scott's talks that he gave. There's multiple different versions of this. And his most important design guideline is that interfaces should be easy to use correctly and difficult to use incorrectly. I do not disagree with this premise. However, I postulate that there's something even more important, that interfaces should be designed to be testable. And if you want testability, you actually have to design for testability. And I'm not talking about TDD where the third letter means design. I'm talking about actual design for testability. Designing things, not just functions and classes, but systems and your holistic thing. Most of us don't just write something that gets run in isolation. They get run with a coordination of other things. So our first priority when designing anything in the software world needs to be testability. I argue that strongly, so much so that I say that if testability is not your primary concern when designing software, that you're doing it wrong. Now, maybe you need to for some reason, that you need to be able to build things that you can't and don't intend on testing. So, why is testing important? Well, testing is important because we're all humans. I mean, every one of us, until the AIs take over, we're humans. And there are two things that every single human is really, really good at. The first is making mistakes. Every single one of us is really good at making mistakes. Even when we try to minimize them, we make mistakes. We're human. And so we should not be surprised when mistakes happen. We shouldn't be surprised when bugs happen. Instead, we should expect them, and we should plan for them. And the second thing is that we're annoyed when everyone else makes mistakes. It's the way it happens, right? Your mistakes They're okay. So I'll get mad at you for making a mistake. But I want you to understand that my mistake was really just a mistake, and you shouldn't get mad about it. In fact, it was because you made your interface too hard to use. That's why I made my mistake. But testability is really important just because we're humans, not because of the software you write or the industry. And all those things are important. But the biggest reason we have to test is because we're humans and we make mistakes. We make lots of them. So when we think of testability, this is what people think of a lot of times. Unit tests and TDD. That's what we think of with testability. In fact, I recently received an email from a friend of mine in the business, someone with whom I worked many years with, and he saw that my talk was published at CppCon, that it was going to be here. He couldn't be here, so he sent me an email, and this is what it said. Now, keep in mind, this guy, he's been programming longer than me and longer than most of you have been alive. And he's really good. He said, I often struggle with how to make my classes testable. I sometimes find that the issue is hidden state. I then have to find ways to expose and manipulate that state in test cases. Sometimes that causes new problems, typically exposing interfaces that exist solely for unit testing. Putting them in a separate public section helps, but it's less than satisfying. Perhaps another possibly better approach would be to provide a mockable component, but that complicates the programmer's API with more template parameters. I could go on, but I won't. Now, I'm sure these kinds of issues are quite common to you. I hear them often, as do you. So I had to reply to my friend that this talk isn't about those things. This talk is about things other than unit tests and testing small units, because lots of other talks cover those things. This talk is about a view of your system holistically and trying to make things testable, mostly things that you don't ever test. Not just saying that about you. I don't test some of them either, depending on where I am. Lots of people focus on these things. However, as an ode to my friend, I decided to add a section to this talk to specifically describe how I personally deal with hidden state. Now, I would prefer to have a composable design up front because functional composable designs are easy to test. That is not an opinion. They are easy to test, and you don't have to worry about these things. However, a lot of us deal with them, and so do I. So there's lots of times you need to test things, and you want to get to some hidden state. So the code you are about to see is a utility to provide direct access to non-public members of any type in any C++ class. It's fully standards compliant, it doesn't do any tricks, and it's been around since basically C++ 98 was around. I first encountered this technique in something of Dave Abraham's back, I think, in 1998, but I'm sure it's been around in other forms, but Dave is where I first saw it. So, of course, not like this, just the technique in general, because this wasn't around back then. But first, we have a template to provide super user access to a possibly non-public member. So this tag type is a type which describes the access. The auto parameter is what's going to be a pointer to a member, okay? This is just, there's nothing here, right? It's just the primary template declaration. The first specialization just takes a tag type, and it provides access to one class member. Basically, it's going to be a pointer to member. That value is going to be a pointer to member. And this is a viewpoint into the class member. So we'll see the importance in the next slide. Here, this specialization is where the magic happens. When this template is specialized, the non-type template parameter, this member, is provided it can be any member you want, whose access can be anything you want. Private, public, it doesn't matter, protected. Those are really just suggestions, in C++, right? So this has been explicitly allowed since the very first standard. However, access to this member is only available inside of the class that does the specialization. In order to make the access more widely available, we have this. Note the two assignment operators. This is basically publishing that value that we've given it. Basically, we're going to give it like a pointer to a member. And it's going to assign that pointer to the member through that pseudo with the tag T. This is going to make it available outside of this class. Because remember, you can specialize with a pointer to a member, but only when you specialize the class. Otherwise, if you want to access it, you'd have to give it to the pointer to member again, and the compiler would yell at you saying, you're only allowed to do that inside of a specialization. This right here is just a function template. To ease calling it, it's a helper, makes it somewhat pleasant to actually invoke the member that you're going to invoke, whether it's a member variable or a member function. And then this provides a way to create a tag for the pointer to member so that we can pass the pseudo class template along. Okay? Everything up to here can be considered as library components. If you write this once, you don't have to write it ever again. So how do you use it? Let's say you have something like this and you want to have access to that private state. You need to declare a pseudo tag. This is basically defining the class and the type of the protected or private thing that you want access to. And now you explicitly instantiate the template with the class and a pointer to the member that you want to expose. Okay? So remember, in the thing we saw earlier, whenever that pseudo gets instantiated, it gets instantiated with the type and the pointer to member. Inside its value, it's assigning it through an instantiation of pseudo with just the type. So now we can access this protected private thing just with pseudo with the type, which is what we do here. Okay? And so now we have this code that actually allows us to print or do whatever we want. If you can make it const if you want, or you can make it non-const, which means you now have mutable access to this thing. I do not encourage you to write code this way. I do not encourage you to use this willy-nilly for anything you want. But if you're in the state that my friend was talking about, where I'm having a hard time testing something because of hidden state, I don't want to make a bunch of things public, I don't want to do all that stuff, or I can't change the class at all, you can do this in test code in order to get access to these private members. You can make it a little prettier by defining a macro that kind of does the machinery for you, and then all you really have to do is that pseudo thing, okay? So back to test. Anybody any questions about that? All right, anybody wanting to shoot me and kill me because I'm showing people how to test? Yeah, okay, all the people that work with me. All right, good. All right, so back to testability. How many of you guys recognize this guy? Not very many. How many of you recognize him now? Okay, yeah, now, yeah. He is very much focused on eradicating bugs in everything he did. Right? Everything he did, he wanted to eradicate bugs. So much so that he offered bounties for all the bugs that he had. Right? I think Tech had a bounty that it doubled either every year or it doubled every time a bug was reported. I want you to have the bravado to say that I will write a big, huge piece of code, and every valid bug that's reported, I will double the bounty. I mean, it doesn't take very long for you to, I think right now it's only like $300. This has been around for decades. So he loves testing. He tested his software. He proved his software. And sometimes he did only one and not the other, as evident by this very famous line in this not so famous letter. So I think he knows a little bit about programming. I think he knows a little bit about testing. Let's see what he has to say about testability. This was a question from an interviewer back in 2008. In that vein, today's programmers frequently build programs writing small code increments followed by immediate compilation and the creation and running of unit tests. What are your thoughts on this approach to software development? He replies, as to your real question, immediate compilation, unit tests, extreme programming, and TDD combine to form the ultimate silver bullet. I've been waiting my entire career for such an advancement in computer programming methodology. Not quite. That's not his quote. This is his real quote. This is his real quote. As to your real question, the idea of immediate compilation and unit tests appeals to me only rarely when I'm feeling my way in a totally unknown environment and need feedback about what works and what doesn't. Otherwise, lots of time is wasted on activities that I simply never need to perform or even think about. Nothing needs to be mocked up. So think about that. In some circles, this would be considered heresy and not safe for work talk, right? This is not what your professors say, and this is not what you hear on YouTube. Before we go on, I must give full disclosure. I am a huge fanboy. And yeah, that's all. But we're not done with the brilliance of Dr. Knuth. This next question, it says, can you give some examples that are currently in vogue which developers should adopt simply because they're currently popular or because that's the way they're currently done? Would you care to identify important examples of this outside software development? I hate to duck your question, even though I also hate to offend other people's sensibilities, given that software methodology has always been akin to religion. That's just an interesting thought. With the caveat that there's no reason anybody should care about the opinions of a computer scientist / mathematician like me regarding software development. Let me just say that almost everything I've heard associated with the term extreme programming sounds like exactly the wrong way to go, with one exception. The exception is the idea of working in teams and reading each other's code. That idea is crucial, and it might even mask out all the terrible aspects of extreme programming that alarm me. But he's not done yet. I also must confess to a strong bias against the fashion for reusable code. To me, re-editable code is much, much better than an untouchable black box or toolkit. I could go on and on about this. If you're totally convinced that reusable code is wonderful, I probably won't be able to sway you anyway. But you'll never convince me that reusable code isn't mostly a menace. So, there are very few companies that would hire this guy to work for them if he said this in the interview. Right? Donald Knuth would be out looking for a job if this is what he said in the interview. But I really want you to think about what he says, okay? So how does he test? If he's so confident in his testing. I generally get best results by writing a test program that no user would ever think of writing. My test programs are intended to break the system, to push it to its extreme limits, and to pile complication on complication in ways that the system programmer never consciously anticipated. To prepare such test data, I get into the meanest, nastiest frame of mind that I can manage, and I write the cruelest code that I can think of, and then I turn around and embed that in an even nastier constructions that are almost obscene. He calls these torture tests. Okay? Now, these are not, he's not writing little tests as he writes each line of code. He's building things and he's giving input to this thing and expecting it to do something else. And then he tortures it. Now, this actually sounds akin to manual fuzz testing or manual, what we call property testing. And by the way, I'll say, since this is on testability, I personally have found a whole lot better use of property-based testing than detailed unit testing. It tests the actual desired output and alleviates the tendency to being barred down and combined into your implementation. Now, of course, the pseudo trick I showed you earlier, that obviously ties you into the implementation. But that's here's the deal. Every tool has its place. Every tool has its use. And if we get into a place where we are extremists in our programming methodology, we're going to have a hard time solving some problems. So everything has a use. His testing is intended to torture his code. I think using techniques like property-based testing And fuzzing is a really, really good way to go. So how do you test your software? Most of us, well, we write unit tests for little things in classes and interfaces and functions. And some of us even completely avoid what are called end-to-end tests. In fact, some of the bigger names in the industry that teach how to build and design software tell you don't build end-to-end tests. Only build a couple. For me personally, if I had to choose between end-to-end system tests and unit tests, I would prefer the end-to-end system tests every time without thinking twice, just based on my years of experience. I would double down on it. You can clap loudly so everybody else can hear you. I saw it. Anyway. So how do you test? How do you test your software? This is a cruise missile. So when I lived in Florida, one of my best friends was a programmer at a particular company that worked on cruise missile guidance systems. Probably not this one, but that's what he did. He told me how they tested their software. How are you going to do a live system end-to-end test on a cruise missile? Launch it at, who are you going to launch it at? You're not. So what they did is they wrote a module that took the cruise missile commands and converted them into helicopter commands. And so they would take the software up into the air in a helicopter. The helicopter pilot would turn the software on. The helicopter pilot would go, "Look, Mom, no hands." And hopefully the helicopter flies where you want to go. Now, I don't know about you, but airplanes are designed to fly. Helicopters are rocks. If something goes wrong with that thing, it's just going to fall. But that's not the only way that they tested. See, there's a difference between believing in something and being committed to something. The chicken believes in breakfast. The pig is committed to breakfast. So the way that they tested this is that when the box went out and got on the helicopter, the development team went out and got on the helicopter with it. So when the helicopter went up in the air to test, the software was being tested and the development team was in the helicopter with it. Now you tell me that you're going to commit something last minute that's been untested the day before you take that sucker up in the air. Now I'm sure they had other tests. That wasn't their only one. But before it ever went live, they had system end-to-end tests. I'm shocked when I talk to people at how many people in our industry just do not do this. Again, testability isn't unit tests. Consider this function. I test it with the compiler, but you can't test this function with the compiler because it's just full of naked types. If I want this function, I have to write a boatload of tests to make sure that I didn't confuse the price and the quantity. But that means I have to write a lot of tests. But I can get rid of a lot of tests by having a rule that says no naked types. Well, how do I test that rule? Well, I test that rule by making sure that the compiler fails. No naked types, no ints, no bare types, no string, and no price and quantity. But you go, those aren't naked types. But look at this one. You can easily confuse the bid price and the ask price and the bid quantity and the ask quantity if they're just prices and quantities. Make everything that has any differentiation into a separate strong type. Let the compiler completely eliminate entire classes of bugs that you have to test for. Now, I know what you're telling me, but Jody, I can use those raw types because I don't write all those tests. Yeah, I know you don't. That's why they get confused and these things happen. But this eliminates the whole entire. So I was told that this isn't tests. And yeah, you're right. It's not a test, but it's testability. It's making my software testable. Because what's the goal of testing? It's not to run tests. The goal of testing is not to write tests. The goal of testing is not to run tests. The goal of testing is to make sure that your code does what it's supposed to do. And if you do things like this, you have a better chance of making sure your code does what you're supposed to do by design and construction rather than by happenstance. This is testing to me. There are lots of great strong type libraries. I have my issues with each one because they all have to make compromises. I prefer to use libclang and specify them like this and just have libclang spit out my strong types the exact way that I want them to. I strongly encourage you to learn how to manipulate libclang. It is great for doing things that we'll be talking about here. Generating code and testing assumptions that you want to make about your code. So, what do you test? What is an API? But before we go there, this slide appears in every one of my talks, because this is the most important slide I've ever seen. It was the most beneficial thing I had seen. I struggled with C++11. I had taken a hiatus from work. I had gone off and spent several years just coaching, teaching high school math and coaching football. It was awesome. Guy that used to work for me called me back to help him build some stuff. And I'm like, okay, well, this was, I think, at the end of 2012, going into 2013. I hadn't been following C++ since like 2007. It's like, I didn't know what the changes were. I didn't know any of this stuff. So I'm trying to write all this move semantic stuff. And it wasn't until 2014, I think, when this came out. But this is just gold. This is the talk that it appears in. If this is somewhat new to you at all, or if you have any inkling whether you should do it, do it. This is awesome. So I want to shift gears here and talk about testability in another different perspective. Note, I'm not telling you about TDD and unit testing and things like that. You'll get that from a lot of different places. I think when we talk about APIs, we think that it's like a function, but it's not. It's anything that looks or smells like an API. Anything that you use in anything you can write some computer to do something with is an API, right? Anything that you make a request through. So my first job out of university was writing Unix kernel code. But in the 90s, I went to work for a company called Automated Trading Desk. And basically since then until now, the last 3 decades, 30 plus years, I've spent in what's called the fintech space. So this is from Wikipedia, and it describes a company known as Knight Capital. If any of you guys are in the financial space, you know who these guys are, you know my story. On August 1st, 2012, Knight Capital had a software event that caused them to lose roughly $10 million per minute for 45 minutes, or about $166,000 per second. Now, this wasn't continuous. This is just like an average, right? They lost roughly $10 million per minute for 45 minutes. I want to talk about it. It's not exactly what happened, but it's close. And I'm not here to bash anybody. I mean, the people impacted were real people with real lives. And I know some of them. They're not stupid. They're not careless. They're not bad programmers. And more importantly, they're not bad people. But we can learn from this. So I've been doing this a long time, know lots of people, and I'm going to limit my discussion to just the things that are in this public document. This is a cease and desist order issued by the SEC to Knight Capital, and it is not a post-mortem. It basically just tries to do a dry recounting of what was established as facts, okay? I'm going to do my very best to only stick to information that is in this document and not talk about anything else that may not be in this document. Because the purpose is to find technical reasons for us that we can get out of it, okay? So that we can grow and learn and become better. Can you guys read that? I'm gonna read through some of this. While processing 212 small retail orders that Knight had received from its customers. SMARS, which is the Smart Order Routing System or something like that, routed millions of orders to the market over a 45-minute period and obtained over 4 million executions and 154 stocks for more than 397 million shares. By the time Knight stopped sending the orders, Knight had assumed a net long position in 80 stocks of approximately 3.5 billion and a net short position in 74 stocks of approximately 3.15 billion. Ultimately, Knight lost over $460 million from these unwanted positions. Now, a couple things just to note here. They processed 300 orders, roughly, right? 212 small orders. And they executed millions and millions of orders on just these little small ones. And they lost a lot of money. How do these things happen? Well, NYSE, the New York Stock Exchange, was implementing a thing called Retail Liquidity Program. And the Retail Liquidity Program, you get retail orders, and then you need to execute them. And so then you'll send them to NYSE. As a result, Knight needed to make changes to their system because this was going to go live on August 1st of 2012. They didn't have a whole lot of notice because really, they didn't think it was going to get approved. At least some people didn't think it was going to get approved. And so they had less time than they would have to get it done than if they had worked on it for a long, long time. But they didn't write bad code. Their code actually worked. Those weren't the problems. Upon deployment, the new RLP code in SMARS was intended to replace unused code in the relevant portion of the order router. The unused code previously had been used for functionality called PowerPeg, which Knight had discontinued using many years earlier. So they were going to remove source code, and they were for a feature called PowerPeg. They were going to add source code to support a feature called RLP. And this wording is a bit confusing. It basically means that the unused code was still part of the system, because the wording in here is a little bit confused as to whether it was removed or unused. So they had this functionality, and they had stopped using it, but it was still in the system, okay? And so at this time, the new RLP code was repurposed to flag that formerly used to activate the PowerPeg code. Knight intended to delete the PowerPeg code so that when this flag was set to yes, the new RLP functionality, rather than PowerPeg, would be engaged. So they basically just reused, we can talk about it as they reused an enum, okay? Let's just talk about it like that. They had an enum that said PowerPeg was 10, and then they just changed it so that now it's RLP equals 10. Okay, that's something that we can understand. It's not exactly how things go, but that's a reasonable thing to understand. You don't think that's some people don't think that's a bad thing. I've been at places where people have argued with me when I've said, look, we can't reuse enum codes. They go, why? It's not a good thing, but it's not the worst thing in the world. Because, people do it. Software runs. But that's basically what they did. When Knight used the PowerPeg code previously, as child orders were executed, a cumulative quantity function counted the number of shares of the parent order that had been executed. This feature instructed the code to stop routing child orders after the parent order had been completely filled. So this PowerPeg code, basically, you get an order, say for 1,000 shares, right? It's going to farm out some orders. As you get these executions, there's execution for 100 shares. So now my cumulative quantity is the total of all the things that have executed. I need 1,000. I got executed 100. I just got executed 200. So now I've got 300. I just got an execution for 700. So now I've got my 1,000. I'm done. I go away. That's basically what cumulative quantity is. In 2003, Knight ceased using the PowerPeg functionality. So this incident happened in 2012. So in 2003, they stopped using this functionality. 9 years later, it was still in their code base. I'm looking at some of you and you're like, I'm just telling you, this happens. You go look at your code base, your legacy. You've got stuff that's in there that has never, it's not used at all anymore, and yet it's still there. So it's not like these were evil people doing bad, mean, evil things. In 2005, they basically rewrote the code. And a portion of the code that they rewrote involved the PowerPeg, and they moved it around. So this thing that computes cumulative quantity got moved up into a different place in the code. That's basically what that paragraph says. This paragraph Knight did not retest the PowerPeg code after moving the cumulative quantity function. Why would they? They didn't use it. But why was the code still there? Don't look down on them. I would bet that if you were honest, 80% at least of you would say that you've got code in your code base that you know it doesn't get used, but it's still in your code base. Beginning on July 27th, Knight deployed their new RLP code. So August 1st was a Wednesday. July 27th was a Friday. RLP was supposed to go live on Wednesday. So they deployed all their new code on Friday night so that it could run on Monday and Tuesday and be ready to run on Wednesday when the new RLP functionality happens. But during the deployment of the new code, one of Knight's technicians did not copy the new code to one of 8 SMARS computers. Knight did not have a second review. Basically, it's a manual deployment to 8 separate computers. 7 of them got the new RLP code. 1 of them still had the old code that still had the PowerPeg code in it, but it hadn't been used in 9 years, right? So 7, a manual deployment, you got 7 computers with the new code, 1 computer with the old code. Knight did not have a second technician review the deployment, and no one at Knight realized that the PowerPeg code had not been removed from the 8th server, nor that the new RLP code had not been added. Knight had no written procedure that required such a review. So there was basically no code review. One guy goes out, does a manual deployment, misses 1. Why did he miss 1? Because he's careless and he doesn't care about his company and he's a horrible programmer. No, because he's human. He's human. That's why he missed 1. He's just human. And he was darn good too. He's human being. On August 1st, Knight started receiving RLP orders whose customers were eligible to participate in RLP. The 7 servers that received the new code processed these orders correctly. However, the orders sent with the repurpose flag to the 8th server triggered the detective PowerPeg code that's still present on that server. As a result, the server began sending child orders to certain trading centers for execution. So 7 systems doing the right thing, 1 not. That one, the orders that it's getting, it's seeing this, hey, this is a retail liquidity provider order. And it says, oh, yeah, sure, because it's 10. Well, 10 is PowerPeg on this system because they reused the number, they reused the code. When I say code, I don't mean the source code. They reused the coding, the encoding of that value, right? It's 10. And so that one says, oh, yeah, I know what this one is. I see the message. The only difference in the message is that it has this new 10 in it. Now, you might think, but weren't they probably different messages? Well, yeah, they probably were. You probably need to go talk to Mike or Ben or Luke about how you generate messages that can actually check their version differences. They've got an incredible set of open source code that handles a lot of this stuff for you. Anyway, that's a side note. So all these orders, but here's the deal: there were only 212 of them. How are you going to lose $400 million on 212? Well, remember in 2005 when they refactored that code and moved that cumulative quantity computation? Well, because of that, the cumulative quantity computation wasn't being done for PowerPeg orders. And so it says, hey, I need 1,000 shares. I just get 100. Oh, I've got 100 shares. I still need 1,000 shares. Oh, look, I've got 200. I still need 1,000 shares. The cumulative quantity wasn't being computed right. And so it's doing the wrong thing, and it's doing the wrong thing over and over and over again. Although one part of Knight's order handling system recognized that the parent orders had been filled, this information was not communicated to SMARS. Now, in these types of systems, you always have something that's watching what's going on. You have to do reporting. You have something that's watching for your daily P&L. You got lots of things that are watching. So there were systems that knew that this thing had overtraded. They knew that this was going on, but none of that ever got back to the SMARS thing And so it never adjusted. It just kept sending out more and more and more orders. Now, I will confess, this is not a difficult thing to do. In this small company I was in, we had a bug in our system that from the time it started to the time that the system flagged a problem was happening, and a human being saw it and intervened and shut the system off, was less than 60 seconds. And we still lost 7 figures. These are things that can just happen. And it was somewhat similar. A little bit. It had flipped to the side. This wasn't exactly what happened, but think of it as, hey, I got 100 shares. I need to sell 100 shares. Hey, look, I'm going to go sell 100 shares. Look, I got 200 shares. I need to sell 200 shares. I'm going to go sell 200 shares. Hey, look, I've got 400 shares. I should sell 400 shares. I'm going to sell 400 shares. Look, I got 800 shares. It doesn't take long to start accumulating huge positions. The consequences of this failure were substantial, and we already talked about this. This effectively ruined them. SMARS processed these orders beginning at approximately 8 a.m. So the market's open at 9:30. At 8 a.m., this basically says that Knight generated automated email messages, but they got ignored. There was automated email messages that actually said, referenced SMARS and identified an error described as power peg. Knight System sent 97 of these emails before 9:30. So between 8 and 9:30, their system said, hey, there's some problem going on. And all these emails were going. But the problem is that, number one, they were emails. They weren't system logs. You couldn't actually test them and verify them. Number two, who processes the emails? Human beings. And human beings get used to seeing lots of messages every day that they just ignore. Knight did not design these types of messages to be system alerts, and Knight personnel generally does not review them when they were received. These notifications were not acted upon before the market opened, and they were not used to diagnose the problem after. I mean, if somebody looked at it, they go, power peg. I mean, what would you think? Oh, crap, I know exactly what this is. But nobody even looked at those messages until after things had been done. But you can maybe relate to it. This thing is going on. Things are going haywire. You're a programmer trying to figure out what's going on. And this is a very short amount of time. So where did all those extra executions go? Because Knight did not link the 33 account to preset firm-wide capital thresholds. Now, what they're calling the 33 account, in this industry, almost everybody has what they call an error account. Okay, I don't know if that's what their 33 account is, but most everybody has an error account. Where error trades, the exchange told you traded this, but since they don't know who or where it should go, it goes into an error account. But there was no communication back and forth to actually diagnose this. It continued to send millions of child orders while its personnel attempted to identify the problem. So, Knight rolls back. They decide, that's what this paragraph says. They decide there must be something wrong, so we're going to do a system rollback. So they roll back all the code from all 8 servers to the code that they had before. And so now, instead of one server running the old code, you've got all 8 of them. It's not necessarily a bad thing because I want to do a rollback. The problem is they didn't roll back the stuff on the edge that was converting things into RLP orders to go into the system. And so it wasn't a complete system rollback. It was just a rollback of one part of the system. This just made things worse. Stephen Dewhurst is one of my favorite speakers. I'm going to play this clip from one of his talks at CppCon. Hopefully you can hear it.
So how do we get a bug? Here's an observation from many years in the trenches. Most good bugs are team efforts. It requires cooperation from a number of people to produce a really good bug. So one bug here is hoping the comment is enough to dissuade people from sending something that's non-mem copyable.
So as we've seen, good bugs are collaborative efforts. I contend, and so what we want to do is we want to see how do we test this? It's like we talked about a lot of technical things. And a lot of things that you guys go, I wouldn't make that mistake. Why did they do that? Just roll yourself there a little bit. Because I think that if we're honest, none of these mistakes in and of by themselves, would any of you think were catastrophic? And the reason is because I've talked to a lot of you, not all of you, but a lot of you, and most of you do not have tests for the things that we're talking about here to test. And so you don't think they're important enough to test either. I'm not talking about unit tests of your classes and functions. So this is basically a summary of the things that happen. Some things are missed, some things are conflated. I posit that if any one of these things did not happen, any one of them didn't happen, we would have never known about this. It would have been a non-event to us. Maybe they don't lose any money at all. Maybe nothing happens at all. If they don't deploy, if they deploy all the stuff to all 8 machines instead of 7, nobody ever knows and nothing ever goes wrong. Because the new code didn't have any bugs, right? I mean, it was tested and it didn't have any bugs. The new code didn't have any bugs at all. If any one of these didn't happen, then this would have been a non-event. Maybe they used to lose a few $1 million. That's nothing. That's nothing. I mean, I don't want to say that losing a few $1 million isn't nothing, but I mean, it's kind of the cost of doing business. It's something that you can go, man, this is bad. We need to figure out how to fix it, but we don't lose our business over it. When we lost that money at our company, I mean, it's like humans, they make mistakes. You know, that's what we're good at. We're good at making mistakes. Our company was named Automated Trading Desk. So one of the things was that automated is in our name. We should have everything should be automated, right? So we tried to automate those times for failures. Let's look at each one of these in some detail for however much time I have left. Remove old code and add new code at the same time. For me, your biggest question when you're designing anything, a class, a function, any type of API, a script, something that runs in your CI, how are we going to test that? That's what I mean by testability has to be the most important thing in your designs. Is anytime you think of something you're going to create has to relate to software, the first question in your mind has to be, how are we going to test that? And some things are really hard to test, and they're not traditionally tested in our community. And so we just don't even ask that question. We roll right on through. It's why I say it's the most important one, because most times we only ask that when we're writing a class. So remove old code and add new code at the same time. Well, you can separate tasks into smaller chunks, but that's a solution. That doesn't really help you test things. But you can use static analysis tools, and you can have a formal design, right? You can have a formal design that separates things, but I know most of us don't do that because we think the third letter of TDD means design. Code review, that's a good way, but who's involved in code reviews? Humans. What's the number one thing every human is really good at? Making mistakes. Code reviews don't solve the problem either. But what we can do is we can build tools for this. Static analysis tools is the best thing for me on here. Static analysis tools are pretty good at being able to compare. Git is a great way to use to compare the code that you added versus the code that was going and seeing what is going on there. How can we differentiate this? Are we adding code and removing it? Static analysis on the two to tell you what they're doing? This is a hard problem. There's a lot of ways to solve it, not a lot of good ones. But if you're not thinking and asking yourself, how do we keep this from happening? Maybe you do it by policy. Maybe you do it by breaking things into smaller chunks and not allowing big commits. There's a lot of different ways, but you at least need to be asking, how do we test this if we're going to say, I don't want to remove old code and add new code at the same time? What about reusing an existing value for completely different functionality? Such as having an enum that says power peg equals 10, and then changing it such that it's RLP equals 10. If they hadn't done that, this wouldn't have been a problem, because it would have been a different value. The old code's still there, but it's not being triggered by it, because it's a completely new value. But there's problems. Sometimes you want to have efficiency. You only got 8 bits for something, and it's a flag, and you need to reuse some. Then you probably need to rethink. Sometimes you can't. And if that's the case, you need to really, really go an extra mile in doing your analysis. This one's interesting, because basically what you do is you say, yeah, don't do that. But then you get people that will argue with you. Well, it's never hurt me before. You're just old. Which is true. Code review, but that involves humans. Automated tooling as part of CI. Well, that sounds like a good idea, because when you have automated tooling as part of CI, it can actually look at the code that used to be and the code that's there. And you can say, hey, write some tool that tells me if there's a difference, if an enum is being added. I've started playing with ChatGPT lately, so I basically told it. I basically walked it through all the night problems, described it, and I said, hey, what are you going to do? I said, they renamed an existing value. For example, what they did was like having enum where PowerPay equals 3, and they just renamed it to something like NYSE RLP equals 3. And the things it gave me were too general. But you can recognize all these things. And you can imagine ChatGPT giving me like essays on how to do these things. It's not extremely helpful. But it did give me some Java code, but I couldn't read it, so I told it that. And then it gave me some stuff, and it wasn't so great, so I gave it a different prompt. I told it to write a program using libclang. And you're given 2 different files. I want you to tell me what they are. And it actually didn't take long. It was less than a half an hour of me going back and forth with ChatGPT and compiling the C++ code it gave me before it actually had a solution that solved most of the problems I could think of. And then I told it this. Use rapid check to write a complete set of property-based tests. And it wrote a set of property-based tests. They weren't complete. It needed 3 or 4 more prompts, but then I had a pretty complete set of property-based tests for this API. And then I basically told it, now go write me a script that will run this, and write a script that I can put in my CI that runs Jenkins, and it did all the script stuff for me. And so now I have this thing that actually works. It's not production ready. I wouldn't deploy the ChatGPT code. But it's like in a half hour or so, it was able to make some progress on this. But we don't do these things. We have policies that we make as design policies. But if you're not testing it, what good is it? So always, how are you going to test that? They stopped using PowerPeg in 2003, but the dead code was still around, and I gotta go quick. So you can make a policy. Dead code must be removed. Well, how do you test it? Well, you can have some deprecation policies, and some of you may have to have deprecation policies. I can't remove it. It's going to go in 2 years. But if you deprecate code, there needs to be a policy. I know this doesn't happen everywhere. I think this is a rule, and it doesn't even happen where I am. If you deprecate something, there should be a policy that says, okay, it's deprecated. When is it going to be removed? And it gets planned and scheduled, and you go through this policy of a deprecation policy that then you test and follow up with code review and static analysis and code coverage. You can find out what code is dead in your system by running code coverage. You go, but it might not be tested. Well, maybe write some better tests. Or if most of us have 90-something% of our stuff, or 80-some percentage, you go through and then you have somebody audit it. You can have ChatGPT audit it, right? Go see, what is this stuff doing? But you need to be doing these things with your code base. You need to test. If you're going to have a policy, you need to test it. They refactored code in 2005. They moved dead code, and all the tests still passed. Well, similar to the previous one. Deprecation policies, code review, static analysis, and functionality tests. Unit tests, or as Knuth calls his, torture tests. You still need to have functionality tests. But you need to understand, if I'm doing refactoring and moving code, how am I going to detect code that is no longer being used? Manual deployment with no review and no tests. Well, you have a policy, never do manual deployments. It's pretty easy because the system just doesn't allow you to do manual deployments. It has to all be scripted. I can't think of a good reason that you would have a human being do system deployments. I just can't think of one. I know all the reasons that I'm given. They're just not good reasons. All deployments should be automated, every single one of them. There's no reason to have them automated. And then when you automate the deployments, guess what? You can have comprehensive system tests that run after you deploy them. You have a trading system, you bring it up, you run it in live mode, everything. You keep all of the event logs, everything of what went on, you run tests through it. Not only can you run the test live before you bring it up, you can also examine all the event logs later for things that you may have missed. Different components had different views of the same thing. You have to do this by policy, monitoring, but also here's the thing. If you've got anything important happening in your system, you should be using event logs. And I mean, I know event logs get like something different places, but I believe 1,000,000% in event logs. Everything that happens in your system, put it into a log. That way you always have a way of knowing what's going on. And you can write back-end scripts because they're not part of the production system, but the event log has propagated to them, and now they can run in real time and determine, is there something going wrong? This guy's saying it's X and this guy's saying a Y, but they should both be the same thing. And so you can automate these things. Email for important log messages. You don't do that by policy. All logs should be monitored with an automated process. You can't generate lazy logs. You should never generate text logs that go to a human. They should all go to some system that is reading them and determining what's important and letting people know what is important. And then you test those pieces that they're finding the right thing. Rollback made matters worse. If you're going to have rollback, you need to test your rollback. I know you don't do this. I just know you don't, because almost nobody does. Most people do full system tests, including rollbacks. You must roll back an entire system, not just parts of it. If you're going to do a rollback, you probably have to roll back the entire system if they're going to be working together. And this must be included in comprehensive off-hours testing with the real system. So I've got some other stuff to say. I'll just say one thing real quick. This one right here is one of my pet peeves. Generated code, check it into CVS or whatever your repository get. I know you don't do that. Everybody believes it's wrong, but you're wrong. Well, here's the thing for me. If I write a code generator, I will write it in such a way that get diffs are easily seen and that I can check it into my repository. Because I've been bitten by this bug. I've been bitten by this, not as hard as Knight was bitten, but I've been bitten hard enough that I will never, ever do this again. I just won't. Your own code generator. I like code generators. So I think we're out of time, so that's about where we are here. I don't know if you guys have any questions. You can come up and ask, or maybe I just put you all to sleep. But that's pretty much what I got. The big takeaway is this. Testability is not about writing tests. It's not about unit tests. It's not about TDD. Testability is about making sure your system does what it's supposed to do at all times, and not just one component, more holistically. And as a community, we need to think more holistically about our tests and about our systems and about our design. And every single time you make a decision about something with software, the question you should be asking is, how am I going to test that? Thank you. So everybody agrees with me, or... all right. If anybody has any questions, come up. If not, I guess you can go grab whatever the snacks are. If you want to ask me questions, I'll be here. Thank you.